Alrighty, welcome back into this lecture where we start multi-table selects, aka joins. Joins refers nothing more to the fact that we're going to join these tables together before we start selecting fields from them. A couple of important points to understand about joins. You may have tables in a select statement from which no fields are returned. The reason being we need them to join two or more other tables. It's the old transitivity issue. I need to join tables A and D, but to get there I need to go via B and C. So A is to B, B is to C, C is to D. Therefore, you're getting your fields out of A and D that way. Second point, Oracle actually accepts two differing syntax for joins. Way back in the early 80s, when SQL was still evolving, there was no ANSI standard for SQL, and Oracle developed what I view as a much more intuitive way of joining tables via the where clause. We'll take a look at one and only one example of that because it's no longer considered standard, despite the fact that Rick thinks it's probably a much more intuitive way of realizing joins. We will emphasize instead the ANSI standard way of doing joins. We'll take a look at one query where we do it both ways so you can be in your face understanding how they differ. All right, should be great fun. Standard practice at this point now is to go out and pull down lecture 14 selects.txt, open that guy up in your favorite text editor, as well as fire up developer and log in as my store because we're going to run some selects. Let's go.
Okay, let's look at our very first multi-table select statement. Select a.firstname, concatenate a space, concatenate a.lastname as customer, and count as number orders from customers A, orders B, where a.customer ID equals b.customer ID, group by a.firstname, a.lastname, order by a.lastname, a.firstname. Woof. Couple of new things here, so let's start out with the from clause first. It reads, select all that stuff above from customers A, orders B. What do you suppose? Yep, we're going to retrieve fields from either the customer table or the orders table, and I've given them aliases A and B. Now that we know how that works, we can look at our select fields. Looks like we are retrieving first and last name from the A or customers table, and we're concatenating those guys together separated by a space and calling that new field customers. Makes sense. I can live with that strategy. What's this count left paren star right paren syntax? Well, it just says give me the number of rows associated with the group by fields. We specified the group by fields down here. Basically says that once you get all these rows specified within the where clause, go ahead and group them by this list of fields. The count syntax then simply says, give me the number of rows associated with each grouping. Finally, let's talk briefly about this where clause. It simply says take each row in the customers table and join it to the corresponding row in the orders table, where corresponding is defined by equivalent customer ID fields. Very straightforward. What's the bad news? This is old non-ANSI syntax for a join, or more specifically an equijoin because we use the equals operator. We'll look at this query again next using the newer ANSI standard syntax. Net, this syntax is getting us each unique customer name and the total number of orders placed by that customer. Very common query. Let's go ahead and run this baby now that we can properly anticipate the results. Beautiful, 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 beautiful. Science is fun. What's the bad news? This is not ANSI standard syntax, and we're going to give it up effective right now. Okay, as promised, now let's move on to this same query written in the ANSI standard join syntax. Select this same stuff from customers A, inner join orders B on A.customer ID equals B.customer ID, grouped by first and last name, ordered by last and first name. Let's check out the changes. Basically, we replaced our where clause with a modification to the from clause. More specifically, our from clause now reads from customers table, alias A, inner join orders table, alias B, on A.customer ID equals B.customer ID. Same basic idea, just slightly different syntax. Please note the inner join specification. An inner join says only complete this join where both fields involved are not null. If either table were to have a null field involved in the join, that row would have been excluded from our result set. More on joins involving nulls, aka outer joins, in just a couple minutes. Okay, now that we understand the syntax and can properly anticipate the results, let's verify our results by executing this query. All right, beautiful, working fine. All right, now that we're using the ANSI syntax, let's go ahead and give an example using the keyword using. Same exact syntax we've had before, but now we have replaced the on clause with a using clause. Note, you can only use the using clause if the field is the same name in each of the tables. In our case, this inner join is being performed over the customer ID field from each of the customers and orders tables, so the using clause is appropriate. Had these fields been named differently in the two tables, i.e. a bad idea, then we would have been required to use the on clause and specify the differing field names. Again, now that we know what we're looking for, let's go ahead and verify our results by executing the query. Beautiful, working fine. Okay. Time to jack up the degree of difficulty a little bit by adding a couple additional fields. Our new query now reads select distinct A, first name as customer, D, product name as purchasing, from customers A, inner join orders B using customer ID, inner join order line item C using order ID, inner join products D using product ID, order by first name. Let's start with the joins. Nothing surprising here, right? Once we join the first two tables, we just start joining in each of the additional tables until we have our entire set of tables linked together into one big equal join. Did you notice we were able to utilize the using clause here because we did a good job of consistently naming our fields across tables? Had we used inconsistent names, we would have had to use the on clause, of course. In addition, it just so happens that in each of these cases we joined over a single field. Had we needed to join over multiple fields, we would have used the syntax shown here with this on clause for differing field names and this syntax for similar field names using the using clause. Again, no real surprises, just a little hard to say. You have likely guessed that syntax correctly. Okay, back now to our multi-table inner join example. Now that we understand how this thing should work, we can go ahead and execute, and there we are, right on the money. Hooray for science. Next, we're going to discuss outer joins. Outer joins allow for the occurrence of null in the join field. For our example, the country and state province fields of our customer addresses table allow for the occurrence of a null. If we did an inner join on these fields to the state provinces table, we would leave out all those customer address rows where either of these fields were blank. Let's run a couple examples and it will become clear. First, let's run a select star in the customer addresses table to just remind ourselves of what all we're looking at. Okay, all the rows have a valid country and state province. Let's go ahead and update that such we can set a couple of these to null for everybody with a customer ID greater than equal to 107. Now, let's run our simple select star again to verify our expectations. Okay, we have 3 rows now with null country and state province fields. First, let's run an inner join query against this table and the state provinces table. Okay, just as we would have expected, we only get the 2 rows where the state and country fields are not null. Let's try it again with a left outer join instead. As expected, now we return all 5 rows, with 3 of them showing null values associated with the state, province, and country table. Just what we'd expected. Now, just as an example, what would have happened had we used a right outer join instead? Oh, not what we would have expected at all. This time we got all rows from the state provinces table and nulls for city and postal code for all non-matching rows in the addresses table. Probably not what we would have been expecting, or certainly not what we would have been looking for. So how do we remember this? A left outer join means that the table on the left does not contain nulls. A right outer join means the table on the right does not contain nulls. There is a third option. A full outer join infers that both tables may contain nulls. What's the net? I've been doing this forever, and I've never used a full outer join. But there it is. It's valid as syntax. Okay, only one more quick example, and we'll call this lecture a wrap. I want to show you a self-join. As the name suggests, a self-join is when a table joins with itself. Where is this common? Hierarchies. And we just happen to have a hierarchical table in our schema, so let's take a quick look. Check out this query. Select a.firstname concatenate space, concatenate a.lastname as manager, b.firstname concatenate space, concatenate lastname as subordinate, from employees A, inner join employees B, on a.employee ID equals b.manager ID. Looks like we have a self-join because the join is between 2 instances of the same table. In our case, the employees table. Standard inner join syntax, right? What did you expect our results now? Well, we should see a list of rows where both the manager and employee IDs are populated, and where the employee ID of table A matches the manager ID of table B. Let's start by running a simple select star to remind ourselves what this table contains. Okay, 4 rows with 3 of them having both employee and manager IDs populated. All right, now we should be able to anticipate what we expect. Let's go ahead and verify our results. Yeah, perfect. Our expectations are exactly correct, so we can be content that our query is also correct.
All right, that had to feel a little bit like drinking from the fire hose. I understand the first time you start dealing with multi-table selects, it's a little much, but please appreciate that by the time you've run 20 of them, it's old hat, and you're going to be able to knock this syntax out no problem. All right, so what did we learn? Well, we started with old school join syntax, where the join was actually realized within the where clause. Equal joins, to me, actually made more sense that way. Outer joins was a little delicate. If you're actually interested, you could check it out. In the old syntax, outer joins are realized via a plus sign on the side of the outer join table. Can get a little confusing, quite frankly, so probably the ANSI standard is better in that regard. To that end, we will be using ANSI standard joins from here on out. That is, the where clause equating is gone, and we replace it with a from table A, inner join table B kind of syntax, followed by an on field name equals field name and field name equals field name, or using followed by a comma separated list of commonly named fields. Remember the difference between using and on. On must be used when the fields in the 2 tables differ. You can only use the using clause when the field names are exactly the same in the 2 tables. And by the way, if you had a good database designer, they should be. So you can use that syntax. We concluded with a brief discussion of outer joins being the inclusion of fields in the joins that are nullable, and whether they're included in the results set or not. Remember, the concept of a left outer join means the table on the first table in the declaration is assumed to have no nulls, whereas the second is exact reverse with a right outer join. That is, the first table is assumed to have nulls and the second isn't. Just for syntactic completeness, there is a full outer join. I'm about 170 years old. I've never used one. That's how practical they are. You just won't see them. All right. I had fun. We're starting to get into the good stuff, guys. So we'll see you in the next lecture. In the interim, have some fun out there, but learn something every day.